when you are trying to debug a problem in your system, you're doing it because the issue is happening right now.
Troubleshooting and debugging a distributed application is really challenging, and it's a different paradigm than the monolithic one. One of the core things that got us to build Pixie in the first place was how can we collect and surface this telemetry data for microservices applications and make it really easy to work with.
You are listening to the Kubelist Podcast, a show interviewing project maintainers for CNCF Sandbox, incubating, and graduated projects. We'll discuss each project to understand where it came from and discuss the roadmap and plans to continue the project. Hi, I'm Marc Campbell. I publish the Kubelist weekly newsletter dedicated to Kubernetes and the CNCF ecosystem. I'm the founder and CTO at Replicated, where we enable cloud-native software vendors like Puppet, Harness, HashiCorp, Sneak, and many others to operationalize and scale the distribution of their modern on-prem software. Check us out at replicated.com. The Kubelist Podcast is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com. Finally, sign up for the Kubelist weekly newsletter and read previous issues at kubelist.com. On this episode of the Kubelist Podcast, Benjie and I talked with two founding engineers from Pixie. If you haven't seen the Pixie project yet, this is a super cool one in the CNCF observability space. The project is using eBPF to monitor network traffic in your cluster and report on it. Because it's using eBPF, adopting Pixie doesn't mean instrumenting all of your code. The conversation starts out with an introduction to the project and an origin story. We then talk about the architecture decisions and the eBPF implementation some. We went off of the technical topics for a little bit, discussing the recent acquisition of Pixie by New Relic, and then finally we discussed the roadmap and the future of the project. I hope you enjoy listening to Natalie and Michelle explain Pixie. Hi, and welcome to another episode of the Kubelist Podcast. I'm super excited to spend the next little while talking about eBPF and digging into the latest in observability with two of the maintainers of the Pixie project. As always, Benjie from Shipyard is here today too. Hey, Benjie.
Hey, Marc.
So let's just dive right in with some quick intros. We have Natalie Serrino and Michelle Nguyen, both founding engineers at Pixie, now part of New Relic, on with us today. Welcome.
Hey, thanks for having us.
So I'd love just to start with some quick intros. Michelle, can you tell us how you got started with Pixie Labs, this in the observability, the cloud native ecosystem?
Yeah, of course. So I am actually the first founding engineer at Pixie Labs. So it's a funny story. Our CEO of Pixie Labs, he'd actually worked at the company that I was at previously, but we didn't actually share time there when we were at that company together, but he'd heard about me from somebody he kept in contact with. And so he reached out to me and was like, hey, I'm doing this thing. And, we've heard a lot about you and we're excited to have you on board. And yeah, I mean, he described the problem that Pixie was trying to solve. And I was like, yeah, that sounds like, something that people run into every day. And I was basically like, let's do it. And so that's kind of how I ended up at Pixie, just starting off at the very beginning. And, we have our office, just me and Zane hanging out for the first few weeks and months.
That's awesome. I think we're going to dive into that origin story of Pixie here in a minute. Before we do, Natalie, I'd love to hear, your intro, your background story and how you got over there.
Yeah, for sure. So, I guess chronologically, I started out as someone more focused on hardware in college and worked at Intel right out of college. But then I kind of realized that I was more interested in working at a startup environment where things move really fast. And I wanted to work on software where you can ship something to someone that same day, whereas in hardware, it might take actually years to reach a user. And so I made that transition and started working in the data space. And that's where I met Michelle and Zane. And that was really great to work together at Pixie again. And I think that along the way, I tended to join companies that were working on a problem that I personally had before. And so I think with Pixie, as soon as I saw it, I knew that it was doing the thing that I would have benefited from as an engineer when debugging applications. And so that was what got me really excited about it because it was a tool I wish I had had.
Yeah, that's cool. It's always fun when you're working on a project that you're passionate about and you see you actually can use and want to use. It makes you as an engineer really more involved in the product side of the project too.
Yeah, and that's a really good thing about working on something that is targeted at developers because we can dog food our own application every day.
That's true. So let's talk about the origin story of Pixie. You were both there early at Pixie Lab days. Michelle, you mentioned that you met with Zane and kind of helped like at the very, very beginning of the project. Are there any stories that you can share about how the project was created?
Yeah. So, I mean, to be clear, I'm not a founder of Pixie, but actually Pixie was started by Zane and our other co-founder is Sean. And I think it was just an idea that they'd been talking about for a while. And they were like, yes, this needs to happen. And so, they just wanted to go and reach out to the right people, just like me, Natalie, to kind of go and just build this whole thing together.
So wait, guys, before we go any further, will you give us a quick overview of what Pixie is and what it's trying to accomplish?
Yeah, sure. So Pixie is basically an open source tool for debugging Kubernetes applications. And, we felt like when Kubernetes started taking off and microservice started taking off, it decoupled, where your application is running from the application itself and made it possible to scale up a lot of engineering teams running in parallel, working on features and shipping them in parallel to each other. But it also introduced a lot of challenges with observing what is happening in your application relative to the monolithic architecture that was more popular before. And so what we noticed is that, just working as developers in our previous jobs, that troubleshooting and debugging a distributed application is really challenging, and it's a different paradigm than the monolithic one. And so a lot of that challenge was in collecting and surfacing the right data. And we felt like that was a problem that, could be made a lot smoother. And at the same time this was happening, eBPF, which is a really cool Linux technology, was taking off, and it had been around for about 10 years. And there was this opportunity to use eBPF to automatically collect HTTP requests, network statistics, infrastructure metrics, and all kinds of data that previously required a lot of manual instrumentation without the end user having to do anything. And so that was one of the kind of like core things that got us to build Pixie in the first place, which was how can we collect and surface this telemetry data for microservices applications and make it really easy to work with.
So the eBPF stuff is super interesting. For those of our listeners that don't know what that means, can you give us maybe a high level on what it is and why it's so powerful?
Yeah. So one of our coworkers who works most closely with eBPF out of all of us, he kind of has this good analogy that I think makes it really easy for those who just like have never heard of eBPF before. But he says, basically think of it like a debugger, right? In a debugger, you set breakpoints somewhere, and then the program basically, once it hits that point, it stops, and then you go, you can inspect the data, see what's going on in the environment at that time. And so the idea here is like, think of eBPF as essentially that, like a debugger. So in eBPF, you want to attach things to syscalls at the kernel level. So for example, it's like you want to trace like some read syscall. So you can attach essentially your debugger, your probe right there. And so the difference here is that instead of stopping execution and then letting you go and, examine everything yourself in real time, it essentially runs a function. So this function can go and do anything that you want that is like safe within the kernel. And one of those things could be, writing some of the values at the kernel right there to some buffer. And then from then on, you can read the buffer, do whatever you want with that data. But essentially, eBPF is being able to run these kernel functions and basically be able to do that.
So you're able to take these syscalls, and then using eBPF, like that's what Pixie's really doing differently than previous observability products that maybe had different ways of instrumenting the code, or attaching to the process. You're like saying it doesn't matter how your code is deployed, like it's going to run against the kernel. We're going to use eBPF to monitor what's happening at this level.
Yes, exactly.
I think one thing to note is we kind of feel like Pixie has kind of three core pillars about how it works. And we can dive more into the eBPF stuff, but, baseline visibility into your system using eBPF is one of those pillars of Pixie. Another pillar of Pixie is that the data that we collect, we store it locally on your Kubernetes cluster. And that is good for a couple of reasons. The first reason is it gives you a little bit more privacy because this sensitive data is not leaving your cluster. It just stays exactly where it is. And then another pillar that we have with Pixie is that we wanted to make Pixie for developers. And so, as a developer, I want to be able to run really flexible analytics on my telemetry data. I want to be able to use an API and hook it into other systems that I have. And so scriptability and, API driven data access is another pillar that we have. And we've used that to build out some cool applications like, horizontal pod auto scaling on Kubernetes or Slack bots and things like that.
Right. So the big thing, going back to the eBPF stuff, because I think this is fascinating and I want to make sure I understand it all the way. It's not a sidecar. It is not attached to a pod. It is in the kernel space, and it buffers out to, with Pixie in particular, to a local data store relative to the cluster. But this is not a sidecar. This is in the kernel space itself. Is that correct?
Yeah, that's right. And one thing to note is that eBPF is really flexible. It allows you to attach probes to kernel level things like the send and receive syscall, for example. This is really useful because this is the lowest level place that your system is making network requests or doing things, which means that no matter what language your program's running in, we will be able to intercept those calls and collect data using those probes. And that, in comparison with traditional language agents or something like that, that would be targeting like very specific libraries. And so it would be possible to miss some things. So it gives you really good baseline visibility into that. But eBPF also allows you to trace the user space with uprobes. And that, for example, is how we're able to trace encrypted traffic, because we are able to set up a uprobe on a TLS library. And so eBPF actually supports tracing in the kernel space as well as the user space.
So that's access to a ton of data between the K probes and U probes, and you get access to pre-encrypted data. Then if you're, with that U probe you mentioned, the data stays in the cluster. That's great. Can you share what types of data do you actually collect? What's the source that you start with?
So we collect all kinds of data. So I think, as Natalie mentioned before, we collect, request and response bodies by being able to use the U probes to trace like SSL libraries. So we collect like HTTPS response bodies, but even for like different protocols, we're able to parse those things out, right? So if you have Kafka running on your cluster, then we can actually tell you, what are the messages flowing in your cluster, both the response and the request bodies. We also collect, just like basic like metrics about your system. So your CPU usage, your memory. We also, one of the things that I really like is that we get to use eBPF to do profiling. So essentially we have a profiler that's always running on your system, and it just pings just like, what is this like application currently doing right now? And with that, we collect like just a sample of just like, where's your application spending the most time? And we can use that information to present you a flame graph. So you can go and be like, oh, I'm spending a lot of time in this function and I don't expect to, so let me go and optimize it.
Something that I'd love to understand a little bit better. Pixie Labs built this really great standalone project. It's a CNCF sandbox project now. You went through an acquisition and you're now part of New Relic. And New Relic, I'm sure, adds a ton of value in lots of different ways, both to the product and the engineering team and in the vision. That's a lot of data that you collect. What can I do with just Pixie? What do I need integrations into third-party systems? Where do I start to get value by, integrating multiple systems versus just running the Pixie project by itself?
Yeah, so Pixie, what we try to do is that we try to give you debuggability in the last 24 hours. Because most of the time, when you are trying to debug a problem in your system, you're doing it because the issue is happening right now versus, it's like you probably won't go and be like, oh, my latency was like super slow last week. I mean, you might, but Pixie is kind of designed for just like that real-time use case. So we really only guarantee, the last 24 hours of data when you're running in Pixie. And that is in part like, we're storing everything in memory and it's unsampled. So we don't want to retain too much data in your cluster that you may not necessarily need. So Pixie is kind of more for that 24-hour time frame. So like where integrations like New Relic comes in is that we can ship, long-term data to New Relic for like further downstream processing or storage, or we might also like use New Relic for features like alerts, for example. Like Pixie, we don't have alerts built out yet because we know that there's a lot of great players out there who've already thought about that problem. And so we kind of, let other integrations handle that kind of thing.
Yeah, I think the important thing to emphasize here is that Pixie is a fully open source CNCF project. And what that means is that there's no requirements to use a third-party vendor to use Pixie. Now, it is possible to use our API to integrate with other applications. Like we've seen people write an exporter to various other environments. Kelsey Hightower actually once did a demo with Pixie, and he's one of the members of Pixie's board where he exported Pixie data to Prometheus. We also have a plugin to use Pixie data in Grafana. So New Relic has an integration with Pixie, and so that is a really good way to get some of the features like Michelle was saying that Pixie doesn't offer, like long-term storage, but you can just use Pixie today out of the box, fully open source, and you never have to actually use a third-party vendor if you don't want to. And then we have a UI with different views of your cluster that comes part of that.
Cool. So Pixie's like value that you're trying to provide as just the core Pixie project is, collecting data like automatically, finding and using eBPF to do this without code instrumentation or anything like this, and retain, you said, Michelle, 24 hours of data, because it's like,
yes.
It's effectively, it's very useful for like debugging a current problem. Like, why is this thing happening right now?
Yes, that is exactly correct. And I think as a whole, kind of what we want to use Pixie for is to establish like baseline visibility into your system. So it's like off the bat, without you having to do anything, it's like you already get a clear idea of like, what does your whole cluster look like right now? And so it's not just like, oh, I'm actually actively like debugging a problem, but also just like for you to take a look and be like, yes, okay, I understand this is what things are looking like. Latency is still doing okay overall. And yeah, it just like also gives you visibility like which services are talking to which. Cause it's funny, we've actually run into some people who are like, oh, these services, they should definitely not be talking to each other. There's a bug with Pixie. And then they realize, oh wait, actually these are talking to each other and it's not supposed to. So like kind of giving you information about that, not just like, oh, things are on fire right now. Let me try to go and see how I can fix it.
Yeah, I think with the UI, one thing that really motivated me when we were designing it is that we have all of this unsampled data in the past 24 hours, like Michelle was saying. So we have things like all the SQL queries that you ran or the HTTP requests you have or like profiles. And I think one place that I can get frustrated with a lot of observability tools is I see a chart, I see a time series of request latency or something like that, but I don't really have a way of drilling down into individual requests or individual things that happened. And so I think one thing that is cool about doing the unsampled way of computing all of this stuff is that with Pixie's UI, you can drill down from really high level views of the system and diagnose like very specific problems. So we, for example, use a profiler to diagnose when we've had a performance regression where we're using too much CPU in a subsequent release. And so you can start off looking at the high level details of the deployment and then drill down and see that this specific function is taking longer than it used to.
So guys, just real quick, I'm at the GitHub project page and I see the Pixel domain language here. Tell us about how we can use that with the data and what that stuff's for.
So, I think that's something that we're really passionate about because we want to not only collect this data, but we want it to be possible for people to write queries to answer specific questions that they have. Because we don't want it to just be only like canned results and then you can't go into something really specific because a lot of times, like, when you're debugging a problem, there's something in particular that's going wrong and you want to isolate that particular type of thing. And so Pixel is basically Pixie's query language for working with data. And one goal that we had with making Pixel is that we didn't want people to have to learn another query language. Like there's a lot of query languages out there and it can be burdensome to learn all of them. And so what we wanted to do is make Pixel completely compliant with Python. So it looks just like Python. And we also didn't want to reinvent the wheel. And so we wanted to follow in the footsteps of Pandas, which is a really great data analytics library for Python, and just follow the Pandas syntax for doing things like aggregates, joins, filters, and things like that. And so using Pixel, you can say things like, hey, like what were the requests that this pod got in the past 5 minutes? But you can also say things like, what was the most frequent value for this field in my HTTP requests? Or any kind of custom analytics that you would want to run, you can use Pixel to do that. And you can pipe these Pixel scripts into our client API and hook it up with other systems in a programmatic way. But Pixel is the thing that backs all of the views in our UI. So you can customize or extend those to fit your unique needs as well.
So Pixel runs on my cluster. Like there's no client. Well, I guess the client is on the cluster where the data is stored as well. So it's basically an API with a nice scripting, Pythonic scripting language to like get all these insights that you guys are collecting for us for the last 24 hours. Is that right?
Exactly. Yeah. All the queries run directly on your cluster.
That's really cool. So have you guys seen some the community engagement around the Pixel language? Have you guys seen some like contributed scripts? If I wanted to go look at some samples, is that an option, or is that not something that's been developed too much yet?
Yeah, so our scripts, we actually have, they're completely open source as well. And we've had a lot of like interesting use cases from like a security standpoint, for example. So using Pixie data to go and, figure out if there are like SQL injections occurring in your system. So that's just an example of like some of the scripts that we have contributed. But yeah, everything is completely open source, and we definitely welcome use cases from everybody. Cause I think at the end of the day, like the nice thing about this community is like, yes, your application is different from the other person's, but kind of at the core of it, you kind of want to monitor a lot of the same things.
Yeah. One thing that's really cool is that, we recently had a guest blog post from a user in our community. So we said that Pixel is the language for querying data in Pixie, and that's true. But one thing that we didn't add is that you can actually use Pixel to get Pixie to collect new data sources without redeploying your application. And one of the ways that we power this is that we support running BPF trace scripts in Pixie, and you can put that as part of a custom Pixel script. And so we have this one user in our community who wrote a great blog post about how he wrote BPF trace scripts and deployed them with Pixie to collect custom data sources in his cluster.
That's actually super cool. I'm actually curious when we talk about community and use cases and stuff like that. There's a lot of observability tools out there, and Pixie seems to have a pretty unique and special take on like the Kubernetes native, cloud native, like way of approaching it using modern technology. Has anybody shared any stories that you're able to share, obviously redact names and everything like this, around like, hey, this long running problem that we've been fighting for a long time, like Pixie was able to finally uncover and help us figure out what the actual root cause was?
Yeah, so it was kind of funny at KubeCon because we were talking to a bunch of people that were using Pixie, and like we hadn't ever interacted with them before. So it was just a sign that we were kind of in a different phase of the adoption compared to the really early days where we intimately knew every user. So they came to us and basically said that they kind of use the profiler that we have in a similar way that we do, which is they run the profiler on their various releases and then are able to diagnose performance regressions from release to release before it happens in production. And as Michelle said before, we've had a lot of cases where people have realized that this thing shouldn't be talking to that thing, and they realized it just by, using Pixel and seeing the communication between the resources in their cluster.
Yeah, that's seems like a really super powerful functionality that you get by like looking at the kernel level and not instrumenting code. So, somebody accidentally is connecting to, or architecture sometimes can, grow organically, and you want a team, an SRE team or a platform team who looks at it and says, this isn't the way that we should be moving this forward. But getting the ability for them to diagnose, discover that is like really, really powerful to offer at the platform level.
Yeah. And we can't, name names or anything like that, but there are a lot of cool customers that we have, or users that we have rather, who, their Kubernetes cluster is running at the edge. It's not a traditional cloud-based application. Mm-hmm. So they have edge devices running in some particular physical context. And Pixie is a really good fit for those use cases because they can run it directly on the cluster, and there isn't this necessity of exporting like gigabytes of data phoning home to some remote cloud. And so that's been an architecture that we're particularly excited about, like people using Pixie on the edge. So
I have like multiple clusters in my organization. Pixie running in all of them, does it kind of like exist inside the cluster? So I can obviously monitor the pods and the activity that's happening there. But when we start talking about network activity and who's talking to what, is it really like internal to the cluster network that Pixie's focused on, or also like, ingress and egress traffic?
So yeah, we do track traffic within the cluster itself. So for example, you mentioned that if you had an account with, multiple clusters that are running Pixie, we can't tell you that, oh, this pod in this cluster is talking to this pod in the other cluster yet. It would just be like this pod in this cluster is, talking to this IP. So we haven't resolved that yet. We do have some basic, just like, DNS resolution, but, for the most part, we show you just like IPs if it's something that's external to the cluster.
Got it. Let's go back to like the challenges originally when you built it, creating this project from the ground up using eBPF, not a ton of resources available, not like a technology that everybody was intimately familiar with. And there was probably a lot of learnings that you had to go along the way. You were both there at the beginning and you went through that process. Can you tell us like what were some of the most technical challenges involved with getting Pixie to actually like live, to work?
Yeah, so I think Natalie and I can better speak to just like everything else on top of eBPF. So the team member that I mentioned before, he is the one who can speak most deeply about eBPF. And I mean, I do know some of the problems they ran into in the beginning there, but I can't speak to it as well as he can. So maybe we can talk a little bit more about like, what are some of the problems that we ran into when just like thinking through the architecture for Pixie, for example, right? Like Natalie mentioned earlier, we do have like the use case that we strive for is just like being able to do everything on the edge because we're storing everything, in memory. And so that's like some of the problems there that we've run into is just like, how do we efficiently store all of this in memory? We're collecting so much data, right? So like if we want to actually retain 24 hours of data, then we need to be able to like build, a very good, basically data model for this. And so that's like some of the things that we did very early on at Pixie was trying to figure out what that data model looks like. How do we compress that data and, what tools should we use for that? And so I think some of that foundation that we built early on in the beginning has allowed us to just like be able to collect and store all of this data for 24 hours.
I think that getting started, one of the main problems that I think about with Pixie is the fact that we run so much on the Kubernetes environment means that we have to do both the data collection side that most tools do, as well as the processing side that most tools do in a cloud environment, and put both of those things directly on the cluster. And a lot of times these are people's production clusters. It's very important that we are able to execute this stuff in a really safe and performant way because, otherwise you could disrupt someone's production application. And so I think that one thing we focused a lot on was CPU. And we often hear the concern from people like, okay, if you're using eBPF, does that mean that it's just going to use a ton of CPU and hog up a lot of those resources? And so it was important to us to guarantee to our users that we would use less than 5% CPU, for example. And so that takes a lot of engineering effort to not only build this application, but optimize it to the point where it can run on these sensitive production clusters.
There's a lot of engineering effort just to like be able to actually like confidently make that guarantee of less than 5%. And like, I mean, it sounds cool. It sounds like some of the stuff that you were talking about earlier, where you're using Pixie to look for regressions in performance with the next release of Pixie so that you can like confidently know that like you're still staying below that advertised threshold.
Yeah, for sure. And then, even though, another person focuses more on the eBPF side than Michelle and I do, I know that it was initially a challenge to get the data instrumentation working on encrypted traffic, for example. And that took engineering effort to figure out because you can't just use K-probes for that because it's going to get the encrypted data. And we wanted to show the decrypted data to the user because that's what's much more interesting.
Yeah, otherwise you're just able to say that, like, it's talking to, like, there's activity, but like without any details, it's like it's just noise basically, that there's something happening, but like you can't take any action on that.
Right.
I know that it's a CNCF project right now and you're really focused in the Kubernetes world. Is it like a requirement though for Pixie to run inside a Kubernetes cluster? I mean, eBPF is obviously, that's just a Linux kernel functionality. Do you have any use cases or support running it just on, non-Kubernetes environments?
Yeah, so right now, Kubernetes is really our area of focus. I think that we will eventually want to be able to run Pixie on nodes that are not part of your Kubernetes cluster. But I think that for now, there's so much to do with Kubernetes that it makes the most sense for a small team like us to stay really on target on a particular area. And so that's the one that we're focusing on right now.
Okay, great. So I want to bring it back. Over at Shipyard, we do use New Relic, in fact. And so I want to understand how we could use Pixie today and the integration with New Relic. And then I also want to understand, as a follow-up to that, just high level, how was the acquisition? How's it going? It sounds like it's pretty clear that Pixie is a completely separate open source project that's in the CNCF. But obviously, there's all kinds of transitions that happen when an acquisition happens. So I'd love to hear about how I can use Pixie at my company. And then I'd also love to hear a little bit about that transition.
Yeah. So as I mentioned before, if you decide to use the New Relic integration, then essentially you're shipping a lot of like the data that Pixie collects to New Relic for just like downstream ingestion on some of their other products, such as alerts. So for example, it's like you want to alert on something specifically, or just like be able to see, Pixie data with long-term retention, which, as I mentioned, we've kind of focused on the 24-hour use case. So being able to store that data for a longer amount of time is what you're able to do. And just like being able to see Pixie data with just like your normal New Relic offerings.
And so that's just a different data provider in my New Relic console.
Yes, that is correct. Yeah, Pixie is a separate data provider, so you'll be able to see that.
So then on the acquisition side, tell us just a little bit about how that went down and how that's working out.
Yeah, I think we're super excited. So New Relic, essentially what they decided to do is just they made this decision that, open source is very valuable to the observability community, just because once this group all bands together, you're kind of all solving the same issues, and being able to use an array of different tools to solve your observability needs is just crucial. And so they realized the importance of that, and they saw Pixie just working on our own thing. And so I think we were very excited when they reached out with the offer of like, we'd love to acquire you, but, we will give you the opportunity to go ahead and open source Pixie. And I think for myself in particular, I was just really on board with that, because some of the things that I thought that was really special about Pixie before we were acquired was just like this community that we're able to build up like very naturally. Like we had this thing called like our Pixie Knot meetings, which were essentially every month, where we met with a lot of people who are just excited about Pixie or just like users of Pixie, and just like showed them what we were working on and just got feedback from them. And then being able to just like have this strong bond with the community, and then just like continuing that with open source, where now we allow like everybody to go ahead and just like freely see what we're doing and freely contribute and give us feedback and their ideas, has just been really exciting. So it was kind of just like New Relic saying like, yes, we think that open source is important, and that this product Pixie would be a great part of that ecosystem.
So in addition to open sourcing it, you took it a step further and actually like it's now a sandbox project. You contributed the project into the CNCF ecosystem. Were either of you involved in that decision and the subsequent process that was involved in actually like completing it?
Yeah. So Natalie and I were very heavily involved in just like going through that process, contributing Pixie to CNCF and just like preparing our code base for that. Cause let's be honest, before that we were, like a scrappy startup trying to build everything together. And there's a fair amount of cleanup that needs to be involved when you're like opening your code to the public, and also making sure that we follow all the guidelines. That honestly is what really drove us to be like, we want to contribute our project to CNCF, is just like, vendor neutrality and making sure we kind of follow all of those things when we're going through that process.
Yeah, I feel like, it kind of sounds a little crazy on the surface. Like, why would you acquire a company and then open source it? But the more you dig into it, the more like kind of like contrarian ingenious you actually realize it is, because what we're really provided with Pixie is access to a really valuable data stream. And when people instrument their code or put data pipelines in their Kubernetes cluster to run pixel scripts or things like that, right? Like there's this sense that needs to be open source, because you are tightly integrating it with your application. And it is really hard for people to have some kind of vendor dependency directly in their own code. And the value that I would say observability vendors have today is taking that data and making it useful. But the data pipelines themselves, those things can be open source because the vendors are providing value downstream of that. And so by open sourcing Pixie, obviously it's got a lot wider of an audience now. Like a lot more people can use it that wouldn't have been able to if it was a proprietary product. And then, New Relic can then take that data and make it really useful and integrated within the context of all the other data that they collect for you. And so I think that it is a really interesting symbiotic relationship, and it shows kind of the future direction that we think that the observability space is going to go, which is more and more open source components, in the application and on the edge, and the value provided downstream of that.
Yeah, that totally makes sense. I think open source for transparency and auditability, because this is access to a lot of sensitive data when it's running in there, 100% makes sense. But even when you think about long-term, ownership and becoming a, steward in the ecosystem so that I can confidently, Benjie was asking how would I get started? But a question that hopefully would be a follow-up question there would be, how do I know that I'm not going to make a big investment in adopting this tool that I'm going to have to rip out in 3 years because of an acquisition and you discard it or something like this. But, Pixie, it sounds like Pixie's put a lot of thought into that by open sourcing it, and New Relic is completely on board, and putting it in the CNCF helps really just shut those questions down.
Yeah, it's all about trust, right? And I think that when a project is a CNCF project, that establishes a promise to the people that use it that says that it's always going to be open source. We're not going to sneak up and change the license on you. This is truly a foundation-owned open source project that you can rely on. And I think that it's a signal that, this is something that we take very seriously.
Yeah, nobody comes and just changes the license on open source projects these days.
Well, the CNCF sure doesn't.
Right.
The CNCF definitely does not.
So that brings up a good point that I want to understand. How does Pixie fit into the open telemetry ecosystem? And are you guys a part of that? Are you guys contributing, or how do you guys look at that?
Yeah, so we're not direct contributors to open telemetry, but we're just honestly huge supporters of open telemetry and just the philosophy of what they're trying to go for. But essentially, one of the things that is from the Pixie point of view, it's we are collecting all of this interesting data, and there are so many tools that you could pipe Pixie to. But what open telemetry kind of gives you is that there's this API for sending that data. So for example, Pixie, we're working on an open telemetry exporter. And so if there was some tool that had an open telemetry importer, then, you can automatically start using Pixie with that tool. So it's just if everybody kind of follows the same standard, then it's just very, very easy to just plug and play with all of these different integrations, essentially.
Great. So if I wanted to use Jaeger, I could use Pixie to feed my Jaeger. Is that right?
Yes,
Great.
Exactly.
Yeah, I think that the thing with open telemetry that's so cool is it's really a huge victory by the open source community to say that, hey, we want the data that is exported by all of these tools or created by all of these tools to be interoperable with other tools. And I want to analyze my data together no matter where it was collected. And so it makes the analytics process so much better when you have that standardization. And it's been really exciting to see the huge adoption that it's gotten among anyone working in observability. And so we're really excited about that and big fans of the initiative.
Initiatives like that are often really, really hard because there's a lot of different, there's a lot of legacy existing products that want to adopt, and then, new folks who want to change the spec a little bit. That's awesome that it's actually working out. I think we've had a different podcast where we dove into the open telemetry project some, but it's great to hear that for Pixie, it's actually a valuable and super useful tool.
Yes.
I'd love to shift gears for a little bit here and chat about the roadmap. You're in the sandbox right now. What is the team working on these days?
One thing that we have coming down the pipeline is obfuscation support and basically redaction of PII. So, in Pixie, we do collect a lot of data, and, maybe if your organization doesn't want, anyone who uses Pixie to be able to see that data. And so we're going to support redaction of personally identifying information. We can support redaction of particular fields. So that is going to be a really cool thing coming down. We are also excited to be able to support larger clusters. Currently, Pixie runs really well on clusters that are 100 nodes or less, but we want to support thousands of nodes in a cluster. And so that is going to be a really exciting project that we're working on.
Wow, there's some really cool stuff in there. I want to ask you real quick about this PII thing. I think Marc wants to ask you as well. How are you guys going to do that in line? And honestly, So I guess that's valuable because if, for example, New Relic is getting piped the data, that needs to be sanitized before it gets over to New Relic in a lot of instances. So I see the use case there, but how in the world are you guys going to do that? Do you guys have an idea?
Yeah, so I think that there's different modes of it. So for people that want the most privacy possible, we can make it so that we don't ever expose the request and response bodies, because that's a way to just guarantee that those bodies of those requests will never, contain any PII because they're redacted in the first place. The other thing that we can do is look for specific data types and basically parse those out from the bodies themselves for people that want to say, hey, just want to make sure no IPs come out, or no addresses, or no credit card numbers and things like that. And so basically the two approaches here are you can look at redacting the entire body, or you can look at redacting pieces of the body based on what kind of category that PII falls into.
Right, but from a technical implementation, is this going to be a scripting language, or like as a consumer of Pixie, how can I, like, is there like scripts that I'm going to do? I'm going to use the Pixie language, or what am I going to do? Or Pixel language?
Oh, I see. Yeah, no, this would just be like a feature that you could turn on. So like you wouldn't have to script it to do that.
Can you tell us a little bit about some of the challenges that you deal with the larger clusters versus the smaller ones that you guys are pretty good with right now?
Yeah, for sure. So basically, we store all of the data in memory. And when you query and say, hey, like, what is my latency over time? We need to actually go to all of the nodes in your cluster and read out all the requests that it got and compute the statistics on top of that. And for a really large amount of nodes and like 24 hours of data, sometimes that can be a longer query, and we want things to be really fast. That's a really strong value that we have with Pixie. And so what we're going to be doing in the new year is basically saying, hey, like, why don't we run jobs that pre-compute statistics and summaries about this data so that when I want to just get the high level view, I could immediately go access it. And the raw data is still there when I want to dive in there. But for these common views that we access all the time, there's no need to reinvent the wheel every single time you look at it.
Right.
And that would basically mean that the query doesn't fan out to every node every single time. So that's like one clear improvement that we can make.
Okay. So, and yeah, just to be clear, so the Pixie runs as like a stateful set on each node.
Exactly.
Right. And by not querying every single node if you don't need to, that's kind of the path there.
Yeah, so there's a lot of opportunity with like summarization of data, better compression of data, enhancements to the query execution. Like there's probably some performance improvements that we can make there. But we've been really happy because we built our query engine on top of Apache Arrow. And we found that that gives us like incredibly good performance for, working with large chunks of columnar data. So big shout out to them for the work that they've done.
That's cool that you're able to use that. All right, let's go on and chat about the community for a little bit. So since you've open sourced and joined the CNCF, I'm sure, like most CNCF projects have community meetings. Can you chat a little bit about how effective they've been, like how you're running them? If I'm interested in in joining and participating in the Pixie community, where would I go? How would I start?
Yeah, so this is basically the Pixie Knot meetings that I mentioned before, but we try to have them monthly, although we've just had like some conventions or conferences lately, such as KubeCon, so we've kind of had those like as more of an in-person meeting. So essentially what we try to do there is just, give people a status update on just like what we've been working on lately. So like demos of like latest features that we've had, and then just kind of open it up for questions at the end for like any questions people might have or just like feedback in general.
Yeah, we also have an active Slack community. It's really great to connect with people on there and hear about their use cases. I think that as the community grows, we're going to be thinking about like how can we facilitate some in-person meetups, safety pending, of course. It's been so great to interact with everyone at KubeCon. We're going to be at KubeCon EU and would love to connect more in person with people, assuming that that still happens. As the community, grows, more mature, I think that we would also like to make more like local meetups as well.
Yeah, that's awesome. As people start coming back, I think that was one of the fun parts of the whole CNCF ecosystem before was like all of the different meetups across the place that you could go to and learn about the projects. So you're recently joined the sandbox. Have you started thinking at all about like what the roadmap looks like and timeline in order to like apply for the incubation level as the next step?
We've actually been talking about it for a bit. So our hope is actually to apply to be, fingers crossed that everything works the way that we want, but we hope to apply to be an incubating project sometime next year.
And do you have like specific roadmap functions that you want to be able to get, or is it just like more adoption and more like end users actually using the product right now?
Yeah, it's more adoption, and also just like being able to say that, this project isn't in good state, to just be able to be an incubating project, and that, we follow the guidelines. And like Natalie said before, that we continue our promise of like, being vendor neutral and being open source.
If there's folks listening to this that are running Kubernetes clusters right now and they're interested, if there was one thing that they could do to help you with that story a lot, right, and get you what you need, is it more, folks in the community meeting, more like end customer, like documented use cases that they're actually running it in production, contributors in the code? What's the biggest ask that you'd have?
Oh man, there's a lot of good opportunities. We have people helping us by, they're contributing new protocols that we can collect, for example. So what I would say is that we have a list of protocols in our docs. If there's a protocol that we don't support, like maybe a SQL protocol or a database protocol that we don't support, we really welcome contributions from the community for that type of thing so that everyone can benefit from it. We like to do guest blog posts as well from people about like what are their use cases, like what have they found Pixie useful for? Like what observability problems have they run into in their work? So, definitely things like that. And also just like help us find places that we can improve the project. Like after a while you look at something for a really long time, maybe you don't see it with the fresh eyes. So it's always super helpful to hear feedback from the community on what they would like to see and, what they think is going well.
So you mentioned that you guys are going to be adding support for Java. So if I wanted to contribute like, Rust or something to that effect, is there a good opportunity there for contributing at the Pixel language level?
Yeah, so that would be in the data collector part, actually. So Pixel is downstream of that. It just queries data tables that get registered in your system. I want to quickly clarify the Java support thing. If we're talking about like tracing HTTP requests or even like JVM statistics, we actually do support that today. But specifically, Java support is in reference to the code level continuous profiler where you can see which functions are taking the most time. So let's say you wanted to contribute the extension of that profiler to other languages besides the languages that we support today. That would be a really cool contribution, and we'll probably get you pretty deep into some eBPF code if that's of any interest to you.
Great. Is there a plan to inject things using eBPF anytime soon, or is it just a read type opportunity for this software?
Yeah, we want to make sure that we made this decision really early on, actually, that we don't want to modify requests that are being sent in the system. We want to just be read only. And so I think that there are a lot of really cool injection use cases for eBPF, and we've seen a lot of other cool projects do stuff along those lines. But for Pixie, we wanted to leave it at strictly observing what's happening and not mutating it.
Great. That's a great distinction there.
I have one more quick question. I'm curious where the name Pixie came from. were either of you involved with naming it or have the story there?
Well, Natalie and I were not involved in naming it, but the idea is that Pixie is supposed to be able to provide magical experiences to people. So that's kind of how that name came to be.
Got it.
So tell us, is there something around the corner with machine learning and Pixie?
Oh, I'm so glad you asked that. I think that's something that is really exciting for us in terms of both features that we have running today and future features. So, a really core part of data science is the ability to run, machine learning models. And because many of us come from a data background, we wanted to be able to do really sophisticated analytics on machine generated and telemetry data. And so one thing that we did, pretty early on is we wanted to make sure that you could run TensorFlow models in Pixel and make that just part of your Pixel script. And so that is a capability that we have today if you want to run a custom model in Pixel. But there's a couple use cases that we have that I'm pretty excited about because it's always annoyed me when I didn't have this before in the past when I was debugging something. One of them is, and this is a very simple application of a model, but we basically say, hey, we know the request path for an HTTP request, right? But a lot of times that request path has a URL parameter in it, like a wildcard or something like that. And sometimes you can end up with like a series of wildcards in a URL. And so one cool feature that we have is actually clustering requests by their logical endpoint that we learn in the system from the examples that you give us. And so when you use Pixie, you can actually drill down into particular endpoints and how they're performing. And this is exciting to me because a lot of times you'll look at the average latency for your service and it looks perfectly fine. But once you drill down into a particular endpoint that may only make up a few percentage of your total requests, you see that it's totally hosed. And getting a service level view of the performance was not enough information. You really needed to drill down into the endpoint itself. And so by clustering these instances of your path into logical endpoints, it makes troubleshooting those types of issues a lot easier. Another use case we have is very similar, where we basically can cluster SQL requests that you're running into logical buckets, even if they get like slightly different inputs or parameters. And so you can do the same thing, but for SQL requests, and see how these clusters of requests behave over time. I think that the way that we think about machine learning in Pixie is, I think a lot of times people approach it with the idea of like, oh, like the machine learning needs to completely solve the problem for me. But we think about it much more like human in the loop assistive. So are there ways that we can cluster the data for you to help you visualize what's going on better? Can we draw your attention to anomalies and weird things? But at the end of the day, the human judgment comes in to kind of classify or categorize what's going on.
So you're talking about anomaly detection baked in just by turning on Pixie, ostensibly.
Well, so the cases that I named were more around clustering data so that you can easily see different logical clusters of requests. But I think anomaly detection is another like really cool thing that, you know, there's kind of like natural support for with the ability to run machine learning models.
And that is running on the node itself in my private organization.
Exactly.
That's pretty powerful. Wow. And that's today. That exists today.
Yeah. So if you want to run a custom model, you know, it may take, you know, some learning about exactly how to do that in Pixel, because it's a very advanced feature. And, you know, we don't expect the average user to be doing that, but it is supported in the language.
Right.
But if you just want to use it today, you can just look at the clustered data and, you know, just see it in action.
Right. Well, that's super powerful. My brain is racing on what I want to do with TensorFlow, and there's so many things. I can't think of one great example other than anomaly detection, but that's really powerful. That's super cool.
Well, I learned a ton about Pixie here today. Natalie and Michelle, thank you so much for joining and sharing. I'm like super excited. I think next week I'm going to go put Pixie on my production clusters and see how it can get some more data from it.
I'm going to put Pixie on our staging servers, but I'm very excited about it. Very excited.
All right, well, thank you, Natalie. Thank you, Michelle.
Yeah, thanks for having us.
Yeah, it was really awesome chatting with you both.
That's all we have time for today. If you're the maintainer of a CNCF project and would like to be a guest on this show, head over to Kubelist.com. To learn more about Heavybit, visit Heavybit.com to check out the library. It's packed with amazing talks and content on sales, marketing, product, and more for founders of developer tools companies. And this podcast is brought to you by my company, Replicated, where we enable cloud-native software vendors to operationalize and scale the distribution of their modern on-prem software to their largest enterprise customers. Check us out at Replicated.com.